Today we are going to discuss exact differential equations. In the previous lecture we were discussing separable and linear ODEs. If you have any question regarding the previous lecture, you can ask. Otherwise, we are going to start exact differential equations. I hope you know what is a differential of a function. In your single variable calculus, you have already studied what is the differential. For example, if we have a function y is equal to f of x, and what is the differential of this function? The differential of this function is dy, and it is what? It is f dash of x into d of x. What does this differential tells us? It basically tells us if we take a very small change in x, then the change in y, the corresponding change in y would be the slope of that function times the change in x. So this is all about if you have any function, for example, this kind of function. So if this is your x1, this is your x2, and this is your small change dx, then the change in y is basically it is this change. So if we change the x to this amount, then what amount of y will be changed on that function? And that change can be calculated by using the slope of that function, slope of that function times the change. So this is we call it differential of a function. The question in the chat window is what clear for everyone. So are you guys can you listen me clearly? Anyone? Just tell me. I think so. That earphone or whatever we call it, we don't have it here. In fact, it is kept here on the table. So if I speak, you should listen to me properly. If you still have any problem, you can tell me. I can ask someone to fix it. So if not, so this is the basic definition of a differential of a function. Now, what if we have this was basically a function y is equal to function of x. It is a single variable function. Y is dependent variable and x is independent variable. Now, what if we have a function which has two independent variables? Function of several variables. For example, if we call it, let we have z is equal to maybe g of x y. G of x y. Now there are two independent variables x and y, and z is the dependent variable. So this was what? This is a single variable function. Its graph is always a line or a curve. But here in this case, the graph is always a surface function, a 3D function. It's basically 3D, and it is some kind of a surface, where this is your function, 3D function. Now, in a single variable calculus, we have to look at the change only in one direction, x direction. But here, you have to look at the change in x direction as well as y direction. So this is your, for example, dx and dy. If you consider the change in x as well as in y, then what would be the change in z? This is what we have to compute here. So if you have a surface function, a function of two variables, two independent variables, then the differential of this thing dz is what? Now, as I told you earlier that in single variable calculus, we take the ordinary derivatives. Means here, if y is equal to f of x, then dy by dx is what? It is f dash dx. You can write, you can have the ordinary derivatives. But here, in this case, in the case of function with more than one independent variables, you cannot take the ordinary derivative. In this case, you take the partial derivatives. So in two directions, you have to consider the change, in x direction and y direction. So in x direction, the derivative will be partial derivative. So it is partial g over partial x. And in y direction, if you compute the derivative, it is what? It is partial g or partial y. So what would be the change in z? Or you can say what is the differential of this function z? Then it will be the derivative of g with respect to x, which is partial g or partial x, into the small change in x, plus partial g or partial y, the derivative of g with respect to y, and change in y. So this as combined will give you the change in z, or the differential in z, differential of z. So in order to compute the small change in z, you have to consider the small change in x as well as small change in y. If you have a function of three variables, for example, if you have here you have g, x, y, z. Z is the third dimension, and here you have some function f of x, so some h function. Then you have to you can raise it. So if you have some function, for example, capital F, which is a function of x, y, and z, then df would be what? Df would be partial f or partial x dx plus partial f or partial y dy plus the change in z. It will be partial f or partial z into z. So it doesn't matter how many independent variables do you have. If you want to calculate the differential of a function, then it would be df, change of that function with respect to x times the small change in x, plus partial f over partial y times dy, plus the change of f with respect to the rate of change of f with respect to z times the small change in z. So this is how we generalize the concept of differential, which you have already studied in the single variable calculus in calculus 1 course, to the functions having more than one independent variable. So just remember that this is how we take the differentials of functions, particularly when we have more than one independent variable. If you have any question, you can ask me. There's a question in the chat window. Let me see it. Okay, there's no question. I hope you get it. I don't want to go into the detail of this thing because we don't need much detail in defining exact differential. So this is all we need here. If you have any question, you can ask me. Otherwise, I'm going to read it. Now, a differential equation of the form an ODE of form. Okay, before that, we should define exact differential. So this is all about differential of a function. Now, what is exact differential? Before defining that, we should define exact differential. If we are given some function, for example, let me describe it. X squared y cubed bx plus x cubed y squared y equal to 0. Now you can see that x squared y cubed times dx. So what is this? This is in fact your partial f or partial x, which we have defined earlier, the expression for the differential. What is this? This is your partial f over partial, what is g over partial y, in fact. So times dy. You forget about the right hand side. Now, can we write this left hand side as a differential of some function, which gives us exactly this left hand side expression? Can anyone tell me? Can we find some function f, okay, f such that f is a function of x, y, and this is in fact what? Partial f of partial x, and this is in fact partial f of partial y. So can we have some function f of x, y, whose differential is this thing? And what is its differential? Its differential is this. You just replace that f g with f, and you get the differential. Now from here, I can see that if I write here 1 by 3x cubed y cubed, and its d means differential. So by looking at the function, here we have x squared x y cubed and x cubed y squared. I can judge, but you don't have to judge it. We'll try to find it. There is a procedure of finding it. So now you can see that if we take the differential of this function, and this function is what? This is your f. This is your f function. If we take its differential, do we obtain this left hand side? Or not f left hand side, you just take this expression. Anyone? Can you tell me? If we take the differential of this thing, do we obtain this expression? Or simply can we write it d of differential of 1 by 3 x cubed y cubed. Now if we apply this definition of differential, we want to take the differential of this function, which is technically this thing, partial f over partial x dx plus partial f over partial y dy. Do we obtain that thing, the right hand side? You can take the derivative here. It is what? You take the partial f of partial x, it will be 3 times x squared by cube, and 3 cancel to get x squared by cube dx plus. Now you take the partial f of partial y, which is 3 times x cubed y squared. So it is basically x cubed y squared. Which is what? This is exactly the right hand side here, this thing. So it means that we can write this expression, or we have a function f whose differential is this thing. So in this case, we call this expression an exact differential. An exact differential. So this expression is what? It is an exact differential, and the function corresponding to this exact differential is what? It is this function. I hope you get it. If you have any question, you can ask. its basic definition, you can look at the definition of exact differential here in my notes, which are already uploaded on LMS. Let me write the definition to you. Just I'll read it for you. A differential expression definition. A differential expression we generally write this expression in this way: m of x y dx plus n of x y dy. Okay, because this is a function of x y, we call it m of x y, and this is n of x y. Is an exact differential in a region R of the xy plane if it corresponds to the differential of some function. If it corresponds to a differential of some function. F of x in that region. So I hope you get now the idea of the exact differential if we have an expression of this form, and if we can write it, this thing in short, d of some function. So here that function f of x y is what? It is 1 by 3 x cubed y cubed. If we take its differential, we obtain exactly the same. Now, if this is the definition of a exact differential, then the exact differential equation is what? Exact differential equation is the definition of this exact ODE. So, a first order differential equation, a first order ODE of the form m of x y dx plus n of x by dy equal to 0. I told you a first order differential equation can have this form as well, okay, in the previous lecture. Then this differential equation of this form is said to be exact, ODE of first order, obviously. If the expression on the left hand side, if the expression on the left hand side, we call it equation 1. Left hand side of equation 1 is an exact differential. Is the exact differential. So, a first order differential equation of this form we call it exact ODE or exact differential equation. If the expression on the left hand side here, it is the exact differential. Just like this, that previous example, if we have a differential equation of this form, for example, let me take an example. Yes. Consider this thing, 2xy dx plus x squared minus 1 dy. Now, can you tell me whether this is exact differential equation or not? Can we find some function which makes this left-hand side an exact differential? Anyone? Can you guess the function whose differential is this thing, the left-hand side of that equation? QD.
Y minus 1 into y. X square minus. I'm not sure, but x square minus 1 into y.
X square minus 1 into y. So, if you're not sure, you just have to take the differential of this thing. So you are assuming that this is your function f of x, y is this thing. Now, we need to take its differential. df is what? It is partial f of partial x, okay, times dx plus partial f of partial y dy. Now, what is your partial f of partial x? You have to take the partial derivative of this thing. And what is this? It is 2x. The derivative with respect to x, you take only the derivative of this thing. Y will be considered as a constant. So the derivative of this thing is 2x times 1 into dx. Plus, now you have to take the derivative of this thing with respect to y. Only y will be considered as a variable, and this thing will be considered as a constant. So what would be the derivative of y here? It would be x squared minus 1 times 1 times dy. So, what is this? Is this the left-hand side of this equation? Yes, it is the left-hand side of this equation. So it means this left-hand side is the exact differential of some function f of x, y. So we see that this differential equation is an exact differential equation. So we can write it d of what? X squared minus 1 times y. Differential of this thing is equal to 0. So this is the function. If we take its differential, we obtain this left-hand side. So we are basically, we have a function whose differential is this left-hand side of this equation. So this equation will be called an exact differential equation. This is what the definition of exact ODE is. I hope you get this idea. If you have any question, you can ask me. You can have a look at these things for a couple of 10 seconds, 15 seconds, and then if you have any confusion, you can ask me any question. But if this is the exact differential, then it is not always easy to find or easy to judge or easy to guess a function f of x, y whose differential is this thing. Okay. For example, if the function you gave might be correct, it is not 100% correct. If I propose another function, this left-hand side is a differential of f of x, y. And I'm going to write it x squared minus 1 times y plus 5. So would it still be the function whose differential is this left hand side?
Yeah.
Yes?
Yeah.
So what is missing here? What you have missed here, you have missed a constant term here. So in general, the function f of x y, whose differential is this left hand side, it should be this x squared minus 1 times y plus some constant, which is basically the constant of integration or parameter while solving the first order differential equation. And it will become the one parameter family of solution if we put it equal to 0. If we put this thing equal to 0, because this equation has equal to 0. So the differential of x squared minus 1 times y plus c is equal to 0. So this function is now what it is, the solution of that differential equation. F of x y, we put it equal to 0 in order to get the solution, one parameter family of solution of the given differential equation. I told you in the previous lecture what is the one parameter family of solution. It is basically the parameter come from the, when we perform the integration of that equation, first order differential equation. Because we need to integrate it one time, so there must be one constant of integration in the solution of the first order differential equation. And that constant of integration basically serves as a parameter, and so we call it one parameter family of solution. These are basically infinite many solutions, because this constant c is an arbitrary constant, and it can belong to, so it belongs to a set of real numbers. I hope you get the whole idea. What is the exact differential of a function and what is the exact ODE, exact first order differential equation. Now the question is, here it was easy to guess some function whose differential is this thing, the left hand side of this. If we have some complicated kind of expression here, in this form, in general, in this form, m of xy times dx plus n of xy times dy is equal to 0. For example, let me write some function here, which is relatively complicated, and it is very difficult to guess the function whose differential is the left hand side of this equation. Might be this equation. E raised power 2y minus y cosine of xy dx plus 2 times x e raised power 2y minus x cosine of xy plus 2y times dy equal to 0. Now, can you tell me what is, can you judge the function whose differential is this left hand side of this equation? So it is very difficult to judge the function whose differential is this left hand side of this equation. So in that case, we must have some procedure for finding that function whose differential is this thing left hand side of this equation. So what is our purpose here? Our purpose here is to find some function whose differential is this thing, and differential of that function is the left hand side, and we put it equal to, in general, some constant c, which is the constant of integration. You saw here this constant of integration, it should come in that function, or you can put it here on the other side as well. You can write this thing, this x squared minus 1 into y is equal to c. Okay? That serves the purpose. So in general, we have to No, not D. उसी तरह आप लिख सकते हैं इसको, लिख दें इसको ऐसे इस तरह लिखेंगे अगर तो सिर्फ फंक्शन के लिए d of some function f of x y plus c is equal to 0 whose differential is that right hand side. Now if you have the differential of this function, how to eliminate this d? It's basically the derivative of that function. So you have to apply an integration on both sides. If you take the integration on both sides, this derivative will be eliminated from here, and you are left with only f of x y, and the integration on the right hand side will give you a constant of integration. This is how you can think about it. So our purpose is to find this function. So we have to find this function f of x y, whose differential is the left hand side of this equation. If you have any question, you can ask me. Is there a question in the chat window? No. Okay, that's great. Now, how to find it? There is a criteria which help us to identify or determine whether the given first order ODE is exact differential equation or not. Criteria. What is that criteria? There's a theorem here which is given here in the book as well as in my notes. You can see this theorem. It's basically the criterion for an exact differential. For an exact differential. So you can read this theorem. I'm going to read, you can see this theorem in detail in the book, but I'm going to give you only the statement or the definition of this criterion. If you have m of x, y and n of x, y, if you have an expression of this form, m of x, y dx plus n of x, y dy, this equation, where m of x, y and n of x, y are continuous functions in that rectangular region, then a necessary and sufficient condition that this expression be an exact differential is, then what is the necessary and sufficient condition for this function to be an exact differential is this thing, partial m over partial y is equal to partial m over partial y is equal to partial n over partial x. So this is the criterion for any expression to be an exact differential. Of an expression of this form, it will be exact differential if the coefficient of dx is m, so remember this, and the coefficient of dy is n. If you take the partial derivative of n with respect to y and partial derivative of n with respect to x, if these two things are equal, then we say that this expression is exact differential of some function. It will be the exact differential of some function f of x, y. So first thing which we should be sure about is that there exists some differential. If we are sure that there is some differential corresponding to this expression, then we will try to find it. If there doesn't exist some kind of function f of x, y, whose differential is this, then we don't want to waste our energies, we don't want to find that. So first thing which we should know that there must exist some function so that its derivative or its differential is this equation. Okay, and then we will move forward to find that function. Now, I wrote this thing here, this example here. Now, if I want to find the differential of, that function which corresponds to the differential of this thing, exact differential, how can we be sure that this thing will have or must have some kind of function of x, y, whose differential? So this is the criteria. Now, in this expression, what is m of x, y? We are going to apply this criteria over this function, so this expression. Or m of x, y is e to the power 2y minus y cosine of x, y. And what is n of x, y? N of x, y is 2x e to the power 2y minus x cosine of x, y plus 2. Now you try to find this thing partial m over partial y. Okay. So partial m over partial y is what? Partial m over partial y. Can you take its derivative and tell me? Anyone? Everyone? You take its derivative and tell me what is the expression, the resulting expression, after taking the derivative of this function with respect to y. What will be partial m over partial y? So, who can tell me? Fatima, Sajid, Hamza, Irfan, Mariam, anyone?
I can try.
Okay. So, you have this function e to the power 2y. What will be its derivative with respect to y? E to the power 2y का derivative क्या होगा? E to the power 2y times 2 with respect to y. Minus, now you have two functions of y here. You will consider x as a constant in partial derivatives. So you have to take product rule here. First you take the derivative of y. First you take the derivative of y, which is 1, and or cosine of xy has it. And then minus, you take the product rule here. Y has it, the derivative of cos is what? Minus sine, minus plus sine of xy times
X.
times x. Because x is considered to be constant here. Now, you can simplify this. It is 2 times e to the power y minus, you can see, cos of xy plus xy sine of xy. This is your partial m over partial y. Now you have to find partial n over partial x. So what will be partial n over partial x? You are going to take the derivative of n with respect to x now. So here you have 2x e to the power 2y, 2 will be considered as a constant. E raised to power 2y is a constant. The derivative of x with respect to x is 1. So what do you obtain here? 2 e raised to power 2y. Now here again you have to apply the product rule. It will give you what? Negative x derivative 1 cosine of xy and minus x as it. The derivative of cos is minus sine, so it becomes plus sine of xy, and then the derivative of angle with respect to x is times y. Times y. And what is the last thing here? 2y. 2y, we are finding the derivative with respect to x. So as the 2y will be considered as a constant, so the constant derivative of this whole thing will be 0. Okay? So we are left with this thing. Now after rearranging, you can see that this term is identical to this term. What does it mean? It means that these two things are equal. Partial n over partial y is equal to partial n over partial x. Partial n over partial y is equal to partial n over partial x. Now, what does it mean? It means that this expression on the left hand side is differential of some function f of xy. Means there exists some function whose differential is this expression on the left hand side of this equation. Now, if we are sure about that there exists some function, then we try to find that function. First, we need to be sure. Now, till here, we are sure now that there must exist some function whose differential is this thing, the left hand side expression of this equation. Now, we proceed further to find that function f of xy. How to find that function? Let me explain that. I'm coming back to this equation because it's relatively easy to show you how things work. Now, this is also an exact differential equation. You can check here partial m over partial y. It is what? It is 2x because the derivative of y is 1. So it becomes 2x equal to partial n over partial x. What is the derivative of this thing with respect to x? It is again 2x. So it means partial n over partial x is equal to partial n over partial. So this means this equation is exact ODE. If this is exact ODE, it means there must exist, then there exists some function f of xy such that df is what? Is this thing. F of xy is equal to constant. You can put it equal to constant. I told you that here why we put this constant. So whose differential is what? It is the left hand side here. This thing 2xy dx plus x square minus 1 times dy. Okay. We need to find this function. Now, this df comes from what? This df comes from the given equation which we are given, and we need to solve. We need to find a solution. Now, what is the common expression of df? It is what? It is partial f over partial x dx plus partial f over partial y dy. Now, what do we call this thing? It is, I call it what? M of xy I call this thing as what? I'm going to generalize this now. I call it what? M of xy. This is 2xy. And this thing, what I call it? N of xy. It is your x here. It means if we write this thing, I'm going to generalize it, this method for you. Here I have an equation m of xy, and here I have normally n of xy. If we compare these two things, if we compare these two equations, or these two expressions, after comparing, what do we get here? Obviously, we will have partial f over partial x is equal to m of xy, and partial f over partial y is equal to n of xy. And we also know that partial m over partial y is equal to partial n over partial x. Remember this criteria. Now, I'm going to take, we call it equation 1, and we call it equation 2.
Sorry, this won't be m of x of y.
See?
M of x of y नहीं होगा delta f
Huh.
upon.
It is m of x1, but in short, I have written it m only. Okay? Now, if I take the derivative of this whole thing, this first equation with respect to y, it means, let me define the other thing. You can start with any of these two equations. Okay, we consider the first equation. Consider 1. अब इस इक्वेशन को आपने फाइंड करना क्या फाइंड करना है आपने f. You have to find the f. How can you find f from this equation? You have to reverse the derivative. Okay. What you do here, you have to take the integration on both sides with respect to x. Integrating, what is the first equation? Partial f of partial x with m of xy. Now, you have to integrating both sides with respect to x. If we integrate both sides with respect to x, then what do we obtain here? After integrating, we get the left-hand side f of xy, because the derivative or an integral with respect to xy with respect to x. Here you have derivative with respect to x. If you take the integral with respect to x on this side, the derivative and integral will be cancelled out and we'll get only f of xy. Whereas here on the right hand side we have m of xy integral with respect to x. So remember that when you are taking integral here with respect to x, you have to consider y as a constant. Okay? As we consider it in the partial derivative with respect to x. So here, while integrating this function, this expression, you have to consider y as a constant. If you are considering y as a constant, then after integrating this, what the constant of integration we should have here? अगर आप यहाँ पे y को constant assume कर रहे थे। तो जब आप इंटीग्रेशन कांस्टेंट यहाँ पे लिखेंगे तो वो कैसे लिखेंगे? Anyone?
Sir, f of y?
Yes, some function of y, not f of y. Some function of y, g of y. Because while taking the derivative in that equation, for example, ये जो यहाँ पे मैंने एग्जांपल लिखी थी, उसमें 2y की प्लस 2y की टर्म आ रही थी आखिर में n में। तो जब हमने n का डेरिवेटिव लिया था रिस्पेक्ट टू x, तो वो 2y वाली टर्म एलिमिनेट हो गई। ठीक है ना हमने? I hope you remember. n अगर आपके पास n of x y, maybe x 2x e raised by y था और फिर minus x cosine of x y था फिर plus 2y। अगर आप इसका डेरिवेटिव लेंगे with respect to x, तो इन दोनों का तो कुछ ना कुछ आ जाएगा डेरिवेटिव, लेकिन ये टर्म क्या हो जाएगी? इस टर्म का डेरिवेटिव 0 है। It means यहाँ पे while taking the derivative of f with respect to x, जब आपने इस फंक्शन का डेरिवेटिव लिया with respect to x, अगर उसमें कोई फंक्शन ऑफ उसमें कोई ऐसी टर्म हुई जिसमें सिर्फ एक फंक्शन ऑफ y है, तो हमने उसको 0 कर दिया होगा। अब उस टर्म को रिवर्स करने के लिए यहाँ पे आपने अगर इसका दोबारा इंटीग्रल लेना है, ये वाला फंक्शन लाना है यहाँ से, तो यहाँ पे आप कांस्टेंट ऑफ इंटीग्रेशन सिंपल कांस्टेंट ऐड नहीं कर सकते। यहाँ पे आपको टेक्निकली क्या करना चाहिए? आपको एक फंक्शन ऑफ y ऐड करना चाहिए जो कि आपने 0 कर दिया था while taking partial derivative of this whole thing with respect to x. So that's why we are adding here some function of y. So some function of y will be the constant of integration here in this case. Remember this. Similarly,
why don't you take x as constant और y को constant क्यों लेते?
जी repeat करें? Can you
Why do you take y as constant? Why can't we take x as constants? Like, how do we decide which one to take as constant?
Because we are taking integration with respect to x. Because we have to reverse the derivative with respect to x.
तो ये y से भी कर सकते हैं। अच्छा, अब आप
We can start with the second equation as well. But here in that case, you will have n of x1. So you have to start from any of these two equations. I'm starting with the first equation.
Okay, makes sense. Thank you.
Now, in order to reverse this derivative with respect to x, what you do, you apply integration by parts, integration on both sides with respect to x. So if you are applying integration with respect to x, यहाँ पे जब आप right hand side पे integration apply करेंगे with respect to x, you will consider y as a constant. Because क्योंकि जब हमने इस f का whatever this f would be, while taking its derivative with respect to x, we have considered y as a constant because this f is a function of x, y. जैसे कि मैंने आपको यहाँ पे बताया, if this is your f of x, y, and you want to take this derivative with respect to x, तो ये 2y वाली term आपने 0 कर दी because you are considering y as a constant. So now while taking its reverse, you have to take g of y as a constant of integration. It may contain a simple constant as well. यहाँ पे आपके g of y जो है, ये assume that this is not only g of y, it is 2y plus 3. It is still function of g of y. It contains a constant c as well. So this is the more general term than a simple constant c. It may contain a constant c as well inside it. I hope you did. That makes sense?
Yeah.
Okay. Now, after using this equation and taking the integral with respect to x on both sides, we obtain the value of this function f of x, y, which is required. We perform this integration, but what is unknown here? G of y is unknown still here. G of y is unknown. How to find this G of y? We'll use the other equation. Okay. If we started with the first equation, we arrive at this. In order to find that unknown function, we'll use the other equation. Now we are going to use this second equation. In second equation, what do we need here? We need the partial f of partial y. We have function f of x, y. What we are going to do here, we are going to take its derivative with respect to y. Okay. Now, if we take its derivative with respect to y, what would be its derivative partial f over partial y of integral of m of x, y dx. Close its derivative with respect to y, partial derivative, remember it, plus partial derivative of a function of y only. It is what? Because it is a function of single variable, we can write it a simple ordinary derivative as well. So it is g dash of y. Because it has only a single variable, so its partial derivative would become ordinary derivative. dg by dy, or you can simply say it g dash of y. You can also write it dg by dy, which is in fact g dash of y. Now, I'm going to use this notation. Now, what is this thing equal to? Using second equation, partial f of partial y is equal to n of x, y. So we can write it n of x, y is equal to partial of partial y integral m of x, y dx plus g dash of y. Now, everything is known here except g dash of y, except g of y. You take this thing on the other side, you will obtain g dash of y. You will obtain g dash of y. So your g dash of y from here, it will be what? G dash of y is equal to n of x, y minus partial of partial y of integral m dx this thing. Because m is known, we can integrate it with respect to x. We can take its partial derivative with respect to y. We have the value of n of x, y, so we have g dash of y. Now we have a g dash of y here. What do we need here? We need g of y here. So in order to find g of y, what we do here, we integrate here. Integrate with respect to y on both sides. So after integrating both sides with respect to y here, we obtain g of y is equal to integral of this whole thing n minus partial of partial y of integral m dx is closed, with respect to y. So remember that you have to consider x as a constant here while taking integration with respect to y. So you have your g of y. Once you have your g of y, after doing this integrations, you can insert that value of g here. So if you put the value of g here, your f of x, y is complete. Now you completely know that function f of x, y, whose differential is this left-hand side of this equation. I hope you get it. If you have any question, you can ask. So we can change this whole procedure of finding f of xy by starting with this equation. If someone wants to start from this equation, partial f over partial y, then you have to integrate both sides with respect to y. Then you find the value of f of xy, but the constant of integration would be considered some function of x. Then you have to write here some function g. G is a function of x. Then in order to find that g of x, you have to use the first equation. So you take its partial derivative of f with respect to x and put it equal to m. So from there, you can find the function g of x. I hope you understand it. If you have any question, you can ask. I think that makes sense. If you have any confusion, you can ask. So let's apply this whole procedure on this equation. I'm going to apply this whole procedure on this equation because it's simple to find, simple to judge, even that function f of xy for this. So we have partial m. First, you have to check whether the partial m or partial y is equal to partial m over partial x. It is the case. We have already checked. Now you start with the. If this is true, then we say that then there exists f of xy such that d of f of xy is what? It is the left hand side, 2xy dx plus x squared minus 1 dy. Yeah, okay. There exists, then there is f of xy such that f of xy is equal to c is the solution of given ODE. Exactly. Now you start with the first equation, partial m or partial x. You integrate it both sides. So you obtain f of xy, integral of m of xy. What is your m of xy? It is 2xy, and you have to integrate it with respect to x. Plus some function g of y. What is its integral with respect to x? It is x squared by 2, and 2 to cancel, you get x squared by plus g of y. So this is your f of x, which was required. But you have an additional unknown function which you need to find here. In order to find here, use the second equation. In order to use the second equation, what you need, you take its derivative with respect to y. So it would be partial f over partial y is equal to, which will be x squared because we are taking respect to y. So x squared will be considered as a constant, and the derivative of y is 1 plus g dash of y. You put this thing equal to n of xy. What is your n of xy? It is x squared minus 1. So n of xy is x squared minus 1 because you have to put it equal to n of xy. And this gives you x squared plus g of y equal to x squared minus 1. So from here, x squared and x squared cancelled. What do you obtain here as a g of y? G of y is nothing but -1. Sorry, g dash. So now, in order to find g dash of g of y, what you do here, you integrate on both sides with respect to y. You have g dash of y minus 1. Integrate with respect to y. Integrate with respect to y. Now, you can add here a constant of integration, but right now you don't need to add it here. I'll tell you later on why. So you obtain here g of y is equal to minus y. Once you have g of y, you have to put it here in this expression in order to find the value of y. Sorry, f of x. So this means f of x y is equal to what? It is x squared y minus 1. If you don't add here the constant c, what you do at the end, you say that this is the expression whose exact differential is this left-hand side. Okay? The differential of this function is this thing, and we can write here the differential of what? This thing, which is x squared y minus y. It is the same as x squared minus 1 times y. This is equal to 0. Now after integrating, what do you get? X squared y minus y equal to some constant c, which is the constant of integration, which gives you the arbitrary constant, which serve as one parameter in the family of solutions. Now, if you would have added a constant here, c, that doesn't change anything. For example, you add here c naught. So here you would have a c naught, obviously. Then you can take this thing on the other side, and you're still with the same function, x squared minus 1 is equal to c minus c naught, which is another constant. You can say this is your c1. So your solution is still the same thing. It doesn't change anything. I hope you get it. If you have any question, you can ask me. This is all about the exact differential equations. Do you have any question? You just look at the solution for a few seconds and then tell me if you have anything. So that's great. If you don't have any question, let's move forward then. Integrating factors. In fact, we have already, in the case of linear ODEs, we have discussed what are the integrating factors. Integrating factor is, the idea of integrating factor is same as we discussed it in the case of linear differential equation. What an integrating factor it does with the equation. If we have a linear differential equation, if you multiply the integrating factor with the left-hand side of that linear differential equation, it will convert that left-hand side into a derivative of the product of two functions. Means that integrating factor combined the left-hand side. We are looking here at the same kind of integrating factor, in fact, which basically help us to find the solutions of the differential equations which are not exact differential equation. If the equation is exact differential equation, then there is no problem. If in case if we have m of x y dx plus n of x y dy is equal to 0 is not exact. Okay, now we are going to discuss non-exact differential equations. Non-exact ODEs. But first order ODEs, remember this. So if it is not exactly, what does it mean? Partial m over partial y is not equal to partial m over partial x. Remember, if the given differential equation is of this form, and we are sure that after finding this criteria that it is not exact differential equation, then we try to look for some integrating factor which converts this given ODE into an exact ODE. That is possible in few cases. For different cases, we can have different integrating factors, but we are going to discuss here only the two cases. For example, if we have this thing and we try to find some integrating factor we denote it by mu of x y. Okay. If we multiply this equation with this integrating factor, for example, mu of x y, m of x y, dx plus mu of x y, n of x y, dy. Now, after multiplying this equation with this integrating factor, we can prove that this resulting left-hand side is an exact differential. Means it will then satisfy this criteria. So if this was m and n, then I call this whole thing as maybe m bar, and this whole thing as n bar. So in that case, partial m bar over partial y should be equal to partial m bar over partial x. So in that case, this equation will become an exact ODE. Once it becomes exact ODE, we can apply the similar procedure which we had applied in earlier examples. We can use that similar procedure to find that function f of x y, which will be the solution of this differential equation as well as the above differential equation. Why? Because multiplying an equation with any factor doesn't change anything in that equation. Because this equation has 0 on the right hand side. अब आप लोगों ने mu of x y से आपने through on multiply कर दिया. So किसी भी constant को किसी एक expression से through on multiply कर दें on both sides, then it doesn't affect on the solution of that equation. This is what the idea is here. Now we discuss how to find that integrating factor. This mu of x y. There are two cases here which we are going to discuss here. Case one. Now you have all these things.
Sir, when does this class end?
G.
Class end कब होती है?
Bas 2-3 minutes. In this case, when you have this equation, you have, if it is not exact, in short, I'm going to write this thing, my, my को मैं m subscript y लिखूँ. M subscript y means partial m over partial y. And this इसको मैं nx लिख रहा हूँ, where partial n over partial x is m subscript x. So the case one is if my minus nx all divided by n is a function of x alone, then integrating factor mu of x y is what? It is nothing but e raised power integral this whole thing. M y minus n x divided by n and integration with respect to x. In fact, this will give you, if this thing is a function of x only, you can write it some function h of x, then this whole thing, then the integrating factor will only be, in fact, a function of x only. Okay, the integrating factor will be mu of x only, because if you are trying to find the integral of this function, sorry, exponential of integral of this function, it will only give you a function of x. This is the first case. The second case is what? Case 2 is if, now it's reverse kind of thing. Now, n of xy minus m, we are changing their positions. N of x minus m of y divided by, well, यहाँ पे n था, अब हम m में लिखेंगे. This, if this expression is a function of y only, a function of y alone, then the integrating factor mu of y is what? Nothing but e raised power this whole thing, whatever you take here, only the function of y. Nx minus ny over m d y. So this will be your integrating factor if this case is true. Let me give you one example quickly, and then we'll finish this lecture. I hope you can see it. Let me give you a single example. A non-exact differential equation made exact. How can we convert xy dx plus 2x squared plus 3y squared minus 20 times dy. Now this is your differential equation, and by verifying partial n over partial y is what it is x, and partial n over partial x is what it is 4x, obviously. So they are not equal because partial n over partial y is x and partial n over partial x is x. Now by looking at these two expressions, if we subtract m y, this is what I call it m y, this is what we call it nx. अब अगर आप इसमें से इसको माइनस करें तो x minus 4x is something 3x, and divided by this thing n, sorry, this thing, and it will not give you some function of x only, because in denominator you will have 3y squared 2x squared, whereas in this case, if you consider this thing, case 2, nx minus my, nx minus my divided by m. What is your nx? It is 4x, minus what is your my? It is x, and what is your m? It is x. So if you simplify it, what do you get? In the numerator you get 3x divided by x, so in short you get 3 by 1 after simplifying. Now what is this thing? It is the function of, this expression is a function of y alone. So this is the function of y alone. What does it mean? It means that its integrating factor will be what? Integrating factor in this case will be mu of y, the function of y only, and it is equal to e raised power. E raised power here you will get 3 over y dy. After solving it, you will get the integrating factor. Now, if you have this integrating factor, now you multiply the original equation with this integrating factor, you will get an exact differential equation. After getting that exact differential equation, you can find the solution by using the similar procedure which we have discussed earlier for exact differential equation. Let me simplify it for you. Now, the integral of this thing is what? E raised power 3 log of 1. You don't have to add here the constant integration. Now, this thing can be written as e raised power natural log of 1 upon 3 e log 10. So, what do you get? Y cube. So, your integrating factor is y cube. Now, you multiply this equation with y cube and then recheck again whether the equation has become exact differential equation or not. If it is, obviously it will be exact differential equation. Then you can solve it by using this technique discussed earlier. This is all about the exact and non-exact differential equation. If you have any question, you can ask.